Okay, so we can start number 22, which is similar to number 21. What is the product of the following reaction? Again, this is a Michael conjugate addition reaction. So when you have the base here, just like the previous one, so the base over here, there are two hydrogens, and base going to go and grab one of those hydrogens. So it's going to form this carb anion, which is going to be stabilized by the two carbonyl groups. It's going to form a carb anion by losing that one of those hydrogens. Okay, and then what's going to happen? This one gonna go and react on to this carbon right there, and then you can see how the conjugate addition take place, one for addition. So we can number in fact carbon, so you will not lose where the carbons are connecting, 1 2 3. So the third carbon is going to attach to this carbon right here. So we can redraw the structure. So this is what you're going to be getting, 1 CH2 CH3. Here you're going to have a double bond. This is number 1, 2 on the number 3 carbon there, and then on 3 you have a methyl group, and the third carbon, so this is the third carbon, and the enolate is going to add. So that carbon has another methyl group. This also has another methyl group, and then this will reform the ketone in that side, giving you the structure, which is carbonyl group from this side, and then here you have methyl group and this group. Okay, 1 2 3. So the third carbon, so then you need to figure out which one is the structure. So the answer A already still has double bond. That's not going to be correct. B also has a double bond. C has a double bond, and D look like it, right? CH, yeah. So do the mechanism and see how the carbons are connected and what is the end product for yourself according to the mechanism I showed you, and then you can find out which one is the correct answer. Again, this information you can find in slide 31, which is same thing like we did in the previous question. Slide 31. Okay, and then the next one, number 23. Oh, now we are moving on to aldol condensation. Which of the following describe the first step in the mechanism for an aldol condensation? We start talking about aldol reactions in the slide 34, 35. Okay, so you can refer to slides 34, 35, and afterwards you will see a lot of aldol reactions. Okay, so in the condensation, the carbonyl oxygen is protonated by the base. Now, read the sentence. The carbonyl oxygen is protonated by the base. Can a base protonate an oxygen? No. So base would normally deprotonate something. So it would be the acid that can protonate a carbonyl oxygen. So the first sentence is wrong. B. An alpha hydrogen is removed by the base to form an enolate ion. Oh, that sounds correct. Alpha hydrogen is acidic, we know that, and a base normally removes to form the enolate ion. So that's correct. And then the base adds to the carbonyl carbon atom. Carbonyl carbon atom, base adds to the carbonyl carbon atom. It doesn't happen. The base is not going to add to the carbon atom. Base will remove a proton. Only the nucleophile will add to the carbonyl carbon. Okay, and then the D, the carbonyl oxygen of one aldehyde adds to the carbonyl carbon of another one. No, it's not the oxygen that is adding from one of the aldehydes. It's the carbanion or the enolate anion. Enolate anion is what's going to add to the carbonyl carbon of the other one, not the oxygen. So D is wrong. Alpha hydrogen is removed by an acid to form an enolate ion. Alpha hydrogen is acidic, and can acid remove another acid? No, it should be the base. So the correct answer is going to be the B. Okay, and then the next one. Again, you can read about and learn aldehydes, aldol condensation 34, 35, and also you can listen to the lecture videos. So all the information is given 36, even page 36, 37. So slides 34, 35 and so on. You can refer to the aldol reactions. And then the next one. What is the product of the following aldol condensation? Now here we have an aldehyde. Okay, so there are two aldehydes. It's going to condense between the two. So this is how it's going to happen. So now this one, COH, and you have another one, two molecules like this, COH. Now in aldol condensation, what happens is one of the compounds, aldehyde, so the ketone, alpha hydrogen will be deprotonated. Let's say you have alpha hydrogen over here, and both of these molecules have alpha hydrogen. So you just pick one alpha hydrogen, and then the hydroxide going to take that and make a negative charge right there. And that is going to be the enolate, formation of the enolate. So carbonyl hydrogen, and then you can have the negative charge right there. And this is going to react with the carbonyl group of the other aldehyde. So this will go and attack this carbon and open up the pi bond. So you are going to make a bond between this carbon and oxygen. You are going to make a bond. So you can redraw the structure like this. This carbonyl group stays there, and then this carbon going to form a bond with the carbonyl carbon. This will become O minus, and then there's a bond right there and this. So the O minus will grab a proton and then become alcohol. You see, from the aldol product you can have, so this is alpha carbon, no, I did the wrong thing, so I counted wrong. So let's erase this one. It's not this carbon, it's going to be, you see, things happen to me also, so it's okay for you to do mistakes. So here, now where is the alpha carbon? Do you see what is the mistake I did? When I was counting the alpha carbon, I chose a different carbon as the alpha carbon. Okay, so now this is the carbonyl compound, so my alpha carbon should be this carbon right there. So the alpha hydrogen going to be this hydrogen. Earlier I chose the beta hydrogen. Excuse me. So now the base will take this hydrogen and form a negative charge right there. So as a result, we will have this molecule, COH, and then the negative charge is right that carbon. Okay, and then this is going to now react with this. Now it looks like a aldol reaction. Okay, so let's see what are the connection that we're going to form. So the alpha carbon of one of the carbonyl compounds form the bond with the carbonyl carbon of the other aldehyde or the ketone. So we have this one right there, that part, and then gonna form a bond here, forming, and this can grab the hydrogen. Okay, this become OH, and this connected to this. Now that looks like a good structure. So you can see carbonyl group and the OH are OH is on the beta position to the carbonyl group, so that is the aldol product. Okay, so you have, and then find out which one is the correct one. So which one looks like the correct structure? CHOH. Did you figure out which one is the correct structure? Okay, I see which one is the correct one. So you can refer which is the correct one by looking at the product that I have drawn. Okay, that's there. And then the next one, what is the product of the following reaction? Again, this is another aldol addition. Now you know how the aldol reaction take place. So there are two molecules of these. So you can draw it. So one molecule, you have 1, 2, 3, 4 carbons. 1, 2, 3, 4. And the other aldehyde also you need to draw carbonyl, hydrogen, 1, 2, 3, 4. 2, 3, 4. So make sure you write the correct number of carbons. Okay, and then these two are going to react, and then the aldol product is going to form. Remember how the aldol is going to work? So one of the aldehydes, alpha carbon, with the hydroxide, the base removing a proton, form the enolate, and this is going to react with the carbonyl carbon of the other aldehyde, and now this will become alcohol. So now you need to connect these two bonds, and when you connect, you can draw your handles like that, and then you form the new bond right there, and this became OH. Okay, 1, 2, 3. So that is going to be the product. So which one going to be the product? You can refer to COH, and yeah, I see a product. Yeah, so you can figure out which one is the correct one. 1, 2, 3, 4. 2, 3, 4. Yes. Okay, so yeah, I see the answer. So this is how, the aldol product is being formed. Okay, all right then. Bye bye.